All right, Math 12, someone messaged me and really had questions about 5.6, which is fractions, rational expressions. So the two things they asked for were questions like number 5 on your assignment, and then just a quick review of asymptotes. So let's do the one like number 5. I actually am choosing page 310, number 70. I think it's pretty similar to number 5 on your assignment. And it is 2x, excuse me, 2x plus 2 over x squared plus 2x minus 15. Oh, nope, that's the wrong one. Sorry, I picked 70 and I was looking at a different one. Let me look at 70. 1 over 2x squared plus 3x plus 1 equals 2 over 2x plus 1 minus 1 over x plus 1. So really the difference between this question and the number 5 on your assignment is really just a matter of there's only one fraction on this side with a trinomial on the bottom, but you're going to treat it just like this one. You're going to treat it the same way. So again, if we are solving for x here, the problem is x is in the denominator. So we want the denominators gone so that it's easier to work with. So the first thing I would say is, listen, I have a trinomial here. That very likely will factor. And it very likely will factor into something like this. So if I have 2x plus 1 and x plus 1, that 1 times 1 would make 1, and then I'd have 2x plus x, which would give me 3x. And very often, if you have to factor one side, it will have components of the other side as well. So even in number 5, when you factor the two bottoms, I'll bet you there will be similar pieces to them. So maybe they'll both have an x minus 5 in it or something. I don't know. I don't even remember what the numbers were. So, so now I have 2x plus 1 and x plus 1, trying to conserve space. So what I would actually do is think about what would be a common denominator, and a common denominator would be all like 2x plus 1 and x plus 1, and I would multiply each piece. So I multiply this by 2x plus 1 and x plus 1 so that everything cancels and I just have 1. So I'd multiply this by 2x plus 1 and x plus 1, and what would cancel would be the 2x plus 1's, and I would have 2 times x plus 1. And here I would have 2x plus 1 and x plus 1. So the x plus 1's would cancel, and I would have minus 1 times 2x plus 1. So when I clean this up, I have 1 is 2x plus 2 minus 2x minus 1. And so I probably picked a weird one because I have that talent. So 1 is equal to 2x minus 2x. I end up with 2 take away 1, which is 1. So in this case, I end up with a weird answer. 9 times out of 10, you're going to end up with x equals something. In this case, I ended up with 1 is equal to 1, which is a true statement, which basically means that any number I put in there would work. It means, because this statement did work out to be true, it means everything would work. And so my answer would be that any x would work. So x would be any real number. Now, again, the chances of that happening are slim. If I had ended up with something that said like 1 is equal to 2, that would mean it's not true and there was no solution at all. I'm just double checking again because I do have that talent of making really stupid mistakes partway through. So I'm just going to see. You may be screaming at your screen right now. I don't know. 5.6 number 70. Yep, they say all real numbers. And they say all real numbers except all real numbers. So they say x could be anything except it can't be -1/2 or -1. Reasons, that would put a 0 on the bottom of a fraction, and you can't have that. So that's basically it. Again, most of the time, 99.9% of the time, you're actually going to end up with an answer. Like your x's won't cancel out, and you'll solve it just like an algebra problem. But you want to factor trinomials, then you want to multiply by common denominators so that things cancel and you no longer have a fraction, and then you can work out your algebra problem. All right. The other question that was asked was, could I do just a quick review of asymptotes? So we talked about two types of asymptotes. We talked about vertical asymptotes and horizontal asymptotes. And what we said was that when you have a vertical asymptote, when is that? You have a vertical asymptote when you have a variable or a letter in a denominator. So if I have 5/x minus 3, there's going to be a vertical asymptote there. The vertical asymptote happens wherever the x value would make the denominator 0. So in this case, if x was 3, that would put 0 on the bottom of a fraction. Hi, Rolls. It's hot up here. Should you be up here? So 3 would be my vertical asymptote. Horizontal asymptotes. If the degree on the bottom, and remember, degree means the exponent on the variable. If the degree on the bottom is bigger than the degree on the top, which in this case it is, because technically that's an x to the 0, because there is no x, and the bottom is an x to the first. So since the bottom is bigger, there is automatically, so there's a vertical asymptote when x is 3. There's a horizontal asymptote when y is 0. In order to graph this, what I would do is I would do a very quick table of values. And I would be picking values that are close to 3 on either side. So say 2.9 and 3.1. And I would also likely pick my x as 0, just because it'll give me a good reference point to put on an intercept. So if x is 0, this would be 5/-3, which would be like -1.666, which would be -1.7. So at 0, it's -1.7. So we'll say 1.7. We'll say that's about there. So if I do 2.9 minus 3 is -0.1. If I do 5 divided by -0.1, it gives me -50. Well, I can't put that on a graph, so what I'm saying is it's down there somewhere. But it never actually touches that asymptote. And this, notice the graph is going up. It's going to continue to go up, but it will not cross that horizontal asymptote. So now I'm going to check 3.1. Or sorry, I did 2.9. I didn't do 2.1. If I do 3.1, 3.1 minus 3 is 0.1, and 5 divided by 0.1 is 50. So again, at 3.1, it's way up there somewhere, and as it comes down, it cannot cross that horizontal asymptote, so it's going to look like that. All right, one more thing I want to talk about with asymptotes, and that should be good. The only other type of horizontal asymptote that can happen is when the degree on the top is the same as the degree on the bottom. Oh, there is one other thing I want to talk about. So, for instance, if we have x/x minus 2. So, for this one, there would be a vertical asymptote at x is equal to 2. And you should not just say there's a vertical asymptote at 2, because is it 2 on the x-axis or is it 2 on the y-axis? Well, it's 2 on the x-axis, so it's x is equal to 2. That is the equation, because it's got an equal sign in it, so that's an equation. So that is an equation of the vertical asymptote. Now, because the degree on the top is the same as the degree on the bottom, we know there's a horizontal asymptote, but its location. What is my dog doing? What are you doing, Rolly? I don't know what he's doing. But it means that we take the leading coefficients, so the numbers out in front of the variables, which in this case is 1 over 1, which is the number 1. So at 1 is where your horizontal asymptote is, and that is y is equal to 1 because it's on the y-axis, right? So that is my horizontal. Again, I would graph this by doing a table of values, and I would likely make x 0, and then I would do something on this side, say 1.9, and something on this side, say 2.1, and I would figure out what those were. 0 would be 0, and what I would find if I figured out my y values is that it's going down on this side and it's going up on this side and coming down, right? So I'm not looking for super accuracy. I do tend to like, if the asymptote's not at 0, I do tend to like to pick x is 0 so I can figure that out. But beyond that, I don't worry too much about it. The other kind of asymptote that I was going to talk about, or other type of equation that I was going to talk about, is one that looks like there's an asymptote, but there's not. It's something called point discontinuity. So if you have x squared minus 4 over x plus 2, it looks like there should be a vertical asymptote at -2. However, there's not, because x squared minus 4 breaks down to x plus 2 and x minus 2. And what happens is the x plus 2's end up canceling and I get x minus 2. What that means is this equation and this equation graphically look pretty much the same. The only difference, because this simplifies to this, that means that it basically means this is pretty much the same as this. So it means this graph has to be the same as this one. So my y-intercept would be at -2, 1, 2. My slope is 1, so up 1 over 1. So my line would look something like this. Now here is where people screwed this up on the test. Again, I remember this. Here's where people screwed this up on the test. The problem was, we said it looked like there should be a vertical asymptote when x is -2. But I said there's not, because that actually cancels out. But there is a problem there, because if I try to go back, if I put -2 into this equation, I end up with a problem, because I have 0 on the bottom of a fraction. That does not in any way stop me from putting the -2 into this equation. If I put -2 into here, I get that the y is -4. So at -2, 1, 2, 1, 2, 3, 4, the graph is here, okay? That's a point on that line. We have to indicate that for this equation, that's actually a problem area. So to indicate that it's a problem area, at that -2 and 4, we put an open circle. What I was finding on a test was a couple of different things. Some people tried to put a vertical asymptote through it. No, there's no asymptote there. So that would have been a no. The other thing that I found kind of funny that people did was here at -2, they put the open circle here. Okay, but that's not on the line, all right? That's not on the line. It has to be on the line, and it's on the line when x is -2, because that's where the problem area is. So go down to your line, put your open circle. If you want to know exactly where that is, just put it into this one. -2 minus 2 is -4. So when my x is -2, my y is -4. So right here, okay? I think that's it in terms of asymptotes. If I didn't answer your question about asymptotes, please let me know and I will endeavor to do a better job. But that's just a quick review of asymptotes, and again, a quick review of a question like number 5 on your assignment. I hope that helped. Bye.